Later today I will give this presentation at a conference, Serum. It's a German conference, and given I have 2 hours, well, I thought I can record it and share it. Okay, I'm going to talk about Jariko, which is an open source JVM interpreter for RPG, and it's written in Kotlin. And we will explain during this presentation what all these words mean. I'm also happy that I'm giving this presentation at a German conference because I used to live in Germany. I've studied as an Erasmus student at the Karlsruhe University, and later during my PhD I spent a semester in Munich at Fortis, an institute of the Technical University of Munich. Unfortunately, I don't speak German. I really try to learn, and one day, who knows, maybe I will manage. Anyway, my name is Federico Tomassetti. I'm the founder at Strumenta, and this talk has been prepared together with Sme.UP. So, let's talk about Sme.UP. Sme.UP is a company, is an Italian company with over 400 employees, and they basically build an ERP. They hired Strumenta to perform the initial design of Jariko, but since then we have worked together on this project, and now lately they've done a lot of the evolution by themselves. So they are partly a client, but partly also a partner for us. And in particular, I would like to thank Franco Lombardo and the Sme.UP Lab, which is the R&D department at Sme.UP, for their help in Jariko and in preparing this presentation. Okay, now let's dive into the problem. What is the problem? The problem is that Sme.UP has a large ERP and a large number of customization built for their own clients. They have thousands of clients, and the core of the ERP and all this customization combined are a very valuable system written in RPG, which for several reasons is not the best of the language, of all the possible languages to use in 2020. Now, what is RPG? RPG is an high-level programming language for business application, which has been created by IBM in 1959. Yes, so that's not exactly the newest language of all. And until very recently, it's been a fixed form language. So basically, the most of code that has been written in RPG is using the fixed form version of the language. And it looks like this. Now, these are a set of data definitions, and you can see that all these lines contain a letter D on the 7th column. And this is because the compiler really needs that letter to be there to understand that these are data definitions. And it's also aligned in this way, not just because the developer had an interest in this layout for readability purpose. It's just something that is enforced by the language. So this is a fixed form language. Now, in this case, we are defining 3 data structures. The first one is name customer info. It has 2 fields, a name of 20 characters and an address of 50 characters. And then we have a product info with a number and a description, and there are whole strings. And then we have a cost. The cost is instead a number of 9 digits, 2 of which are decimal digits. So basically it's a price in which I can specify cents. Then we have a sales transaction. A sales transaction has a buyer, which is a customer info, a seller, another customer info, a number of products, this is just a number, and then we have products, which is an array of product info. and an array of up to 10 elements. we do not have dynamic memory in RPG. So when you define an array, you better have in mind the maximum size that array is allowed to have, because you need to specify it. You cannot dynamically resize your array. Then we have some code, and code in RPG looks like this. This is code, as you can understand, from the letter C on the 7th column. So D for data specification, C for code. In this case, we are defining a subroutine, and you can just get an idea of the language. The language permits to perform assignments. It has control statements like the if, and it has also an interesting statement that will be important for us, that is a call. In this case, we are calling a program named JDURL, and we're passing some parameters. You can notice, well, you can imagine that having annotated control statements inside a language with a fixed format is, well, not ideal, because if you have an if inside an if, then it's really not obvious the else to what if corresponds. So you need to dive a little bit in the code to understand it, or you put some comment on the line. For example, in this case, the first 6 columns are irrelevant for the compiler, so they can be used for comments. You can see that the developer here has put a certain number, in this case 5, on the line of the if and on the line on the else, because they are match. So in this case, if the developer was using I don't know, a lot of if and a lot of else, he could understand the matching by looking at these comments. So as I said, RPG has been a great language when it was introduced. Now it's not the best language ever. But the problem is not only with the syntax of the language itself, but it's also related to the fact that RPG runs exclusively on the IBM platform. IBM is the new version of the AS400 platform. So sometimes I use the term IBM, sometimes I use AS400, same thing for our purposes. Now, RPG runs only on those machines, and so we are locked into the platform. If tomorrow IBM decides to stop selling those machines, well, we have a problem. We have a problem because we have no alternatives. We are the destiny of our code base is connected to the destiny of those machines. And when the destiny of a company is connected to the destiny of one specific code base written in RPG, it means that IBM can decide virtually to kill our company tomorrow if they retire these machines. So that's a risk. Now, what we would like to do is to take the RPG code base, have the possibility to evolve it over time, including code in other languages, in Java and Kotlin in particular, and run all this code on the cloud. To do this in the context of a larger strategy, we have created Jariko, which is this interpreter for RPG. It's open source, so go visit and enjoy it. Now, why we decided to build an interpreter? Well, we want, first of all, to save the huge investment we have done in building this RPG code base. In particular, we have a core and a lot of customization that have been built and evolved to fit perfectly the needs of thousands of customers. So we don't want just to write those, okay? This is an incredible asset for the company. We want to preserve it. However, we want also to preserve the competencies of an army of consultants that the company is using and that know RPG. You should not think of them as developers. Their main skills is the fact that they can understand the need of the customer, they can transform it into customization, they see RPG as a tool. For their need, RPG is okay, so we don't want to retrain them. They will keep using RPG. However, the developers working on the core, instead, they want to use something else because they are developers of their core and they realize RPG is not the best language ever. Also, we want to support the current methodology that they have, that the consultants adopt, that is, they edit files on the fly and they work in a live environment. So they sit next to their clients, the clients explain a problem, they quickly change a data structure, a piece of code in RPG, and show on the live system the change immediately. And this permits to evolve very, very quickly. Now, as a developer, I will never use this approach. I will go through compile and deploy, thousands of tests running. Okay, I reason in a different way. But for them, this is very productive, and we should understand that this is their context and we should support this. Okay. Now, so the plan is to run RPG code into the Java virtual machine. We want to be able to call JVM code from RPG code and be able to execute RPG programs from JVM programs. In this way, we can get a system where the business logic is written in RPG, but the glue code, the infrastructure, is written in Java and Kotlin. So this is in a nutshell the plan. Currently, everyone is using RPG. In the future, consultants will keep using RPG, but developers will use Java and Kotlin incrementally. It means that the core is now written in RPG, so they will not just throw away the core and rewrite all of it in Java and Kotlin. However, with this approach, they will be able to add new functionality, directly writing them in Java and Kotlin, and over time they could replace core part of the systems currently written in RPG, throw them away and replace them with Java or Kotlin if the need arises. For example, if they need to do a large evolution of a specific module, then it could make sense to do that. Now, the way these things will work is that when we will execute RPG code, when we will see a call to a program, we will be able to dope that call, we use this term internally, capture that call and say, instead of looking for an RPG program called JDURL, call this class, in this particular this class has been written in Kotlin, and execute that instead. And you can also see that we use some annotation basically to explain to our Kotlin program how it should convert the RPG values, transform it in values that are native to Kotlin, and then we can just execute our program. Produce eventually some result and return it to RPG that can continue the execution. On the other hand, we have the possibility of taking RPG code. In this case, we have a string containing RPG code, but obviously this RPG code will typically come from files. So we get this code, we convert it into a program doing some elaborations, and then we just call it, get some results, and in this case we are testing, then the result is the result we expect. At a high level, this will be the infrastructure that we have. The client will perform HTTP requests, and they will be served by RPG programs of JVM programs that could communicate with other RPG or JVM programs. Okay. This is an architecture diagram that goes in more details. We are not interested in all the details, but let me just say a couple of things. Now, as I said, Jariko is used in the context of a larger project, right? So we do not have only RPG files, we have also files written in a DSL the company developed that define basically screens. So it defines where components have to be placed into a screen, and we are talking about console applications, okay? So they have written at Sme.UP, we were not involved in this, an interpreter that reads the screen's definition and writes web application instead, okay? While we have help into writing Jariko, and so we can also in the JVM execute RPG code. And then we have a mechanism that we will detail later to provide access to the database that for the time being is still stored on the IBM or AS400 platform. Okay, so this is the context. And it looks like this. In this case, we can read a screen definition that was originally intended to define console application. We can read it, draw a simple web application, a simple screen. This is a screen where I can insert a value, press a button, the confirm button. The system call an RPG program, calculate some values, and show the result here. In this case, we are calculating the Fibonacci value. And this is the RPG code that performs the calculation, or is a piece of the program that performs this calculation. Actually, this is the piece of the code that takes the result and compose the string that we can see here on the right side, and generate the strings by combining string literals with the actual result of the calculation. Okay, so we have already something running on the browser. Well, yes, also on the browser the UI, on the server the rest, but we have already moved an RPG application to the cloud, and we can interact with it through the browser. So this is the final result. Now let's talk a bit about how we can implement an interpreter. Implementing an interpreter means substantially two things. The first one is that we need to understand the RPG code. RPG code is a string, a large string. We need to examine that string. We need to recognize the different parts and what they mean and what is their relation, and build an internal model in a way of that information. And this is what I call understanding the RPG code. Once we have understood the RPG code and we have derived a model, we need to look at that model and execute the instructions that are specified in that model. And this is the second step. Now, the understanding the RPG code step is in itself a complex undertaking. So we use the divided impera approach, and we have defined defined several steps to reach our goal. Our goal is to start from RPG code, a big string, to first split it into single tokens or words, then to organize these words into a structure that makes sense, and this is the parse tree, and later to perform a further elaboration of the parse tree to obtain a structure that is simpler, is more high level, is more similar to the way a human being will think about this program. Okay, while the parse tree is a bit low level, it contains details that are necessary when building this understanding, but we can regard as an intermediate step towards reaching the final understanding of the system. And we will see some example to see better the difference between a parse tree and an abstract syntax tree. Okay, so this is a piece of text. Again, we have in green a string literal with a piece of RPG code, just 4 lines. When we invoke the lexer and obtain the list of tokens, we obtain the list in the gray panel. For each token, we know its type and its content. So, for example, we see that there is a token containing the string value D that has the role ds fixed. So it means that it is a token that identifies a data definition. Then we have other tokens representing a name or an S indicating a type. We have the toPosition token and so on. We have basically split this code into single elements, and we have understood the role of each element that depends on the content, on the kind of string, but also on the position, given this is a fixed format language. Now, later we can parse this code that basically means taking the tokens that we have obtained in the first step and organizing them into a tree. Now, we have this, still the same 4 lines, and for those 4 lines we obtain a parse tree that is on the left of the screen. And you can see it's very long and complex. I do not expect you to be able to read that. I just want to give you the impression that the parse tree is big, even for such a small example. Now, at the center of the screen, I've instead selected a subset of that parse tree, a subset that corresponds to a single line, and this is the line reported below. And so you can see some more details. So it contains some of the token, for example, the dsFix token, the name token, the def type s token, and the toPosition token. And it contains some other optional tokens that in this case are not present, but they could be present. And it also contains some levels, because we have a statement that contains a dspec, that contains a list of tokens, and another node, the ds name node, that contains in itself only one token, the name token. So we are giving some structure to the plain list of tokens we had before, but this will not be easy to work directly with this data structure. So we want to build the abstract syntax tree from it. This is the code we use to build the abstract syntax tree, and this is the result. On the left you can see the abstract syntax tree for the whole examples of 4 lines, while at the center you can see the abstract syntax tree for only the single line reported below. Now this is much more understandable. We say that this is the data definition, in which we introduce no fields, no initialization value, and the name is message. The type is a string type of length 12. So we have combined the information we had in the parse tree, and we have interpreted them. And we knew that what was, well, we can see the comparison here. What was that toPosition token indicated the length of the string, because the fromPosition token had no value. So we elaborate a little bit on the information present in the parse tree, and we prepare it in a way that is much easier to use for further elaboration. So we can see for the same line the parse tree and the abstract syntax tree side by side, and you can see as the abstract syntax tree is simpler, more intuitive. It does not contain some details that were necessary while parsing, but is instead closer to the understanding that the developer would have of this code. Wonderful, but how do we implement actually these steps? Now, to implement these steps, we use Antler, which is a parser generator, for the first two transformation from RPG code to tokens and from tokens to ParseTree, while instead we use Kotlin code to go from the ParseTree to the abstract syntax tree. Now, for the first two steps, we have used an Antler grammar that was written by Ian Eberly, was released as open source, so we took it, we improved it, we patch it, we extend it as needed, but Ryan Eberly did a great job, provided a great RPG grammar, so it really was very useful for us to have this grammar available. Now, I don't want to go into many details here. This is just an example of the lexer, so the tools that takes as input the RPG code and process it and obtain a list of tokens. And this is in particular is a definition of some of the tokens. I want just to give you an impression that with respect to a typical lexer, this is much more complicated because we need to take in account the position that we are in the line. So certain tokens have a certain meaning only if they appear at a certain column in the line. If not, they could mean something else. So a D in column 7 indicates that this is a data specification line. A D in another column could be a name, for example. Then we have the parser part, so the part in which we define, for example, how to recognize expression as a combination of other tokens, but I don't think we have the time to dive into this. Now, to define the abstract syntax tree, instead, we have defined a set of data classes that are basically structures, and we have defined them in Kotlin, where it's very easy to define these data classes and get a lot of functionalities for free. And basically we define a set of nodes, the kind of structures they have, the kind of fields they have. They could contain primitive values, like for example subroutine contains a name, or they could contain other tokens. For example, subroutine contains statements, which is a list of statements, where statement is another node, and so we have these three. Once we have defined the classes that will be used to instantiate the abstract syntax tree, we need also to define the mapping between the parse tree and the abstract syntax tree. To do that, we define extension methods, so in a way we take existing classes and we add some methods to them, and we take the classes that were generated by Antler to represent the parse tree, we add a method to them that is called toAst or toAst, okay? And in many cases this mapping is very simple, is a one-to-one mapping, because for a lot of nodes they are very simple in the parse tree, and we basically want them as they are in the abstract syntax tree. So we define a node which is with a similar name in the abstract syntax tree. We take all the fields or all the children of our parse tree node, and we translate them into children of our abstract syntax tree node. So in many cases this is simple one-to-one mapping. In other cases, however, we want to do some different kind of elaboration. For example, in the case of an identifier, we want to treat certain identifiers in a special way, translating them to different kinds of nodes. These, from the point of view of the parser, were just identifiers. The parser didn't care less if they were corresponding to special identifiers. It was not useful to make this distinction at the parser level. However, for the interpretation later, we want to know that the asterisk blank identifier play a special role, and so we translate it to different kinds of node. Okay, we have also certain identifiers that can correspond to predefined indicators, we treat them specially, and so on. Now, after we have built the abstract syntax tree, we will do further elaboration on these. For example, in RPG, I can implicitly define certain variables inside code. For example, with statement like clear. So if I clear a variable and that variable doesn't exist, I am implicitly defining it. Now, in our interpreter, we want to make our life simpler, so we analyze the code, we find those statements, we extract the implicit data definition, and in a way we make them explicit. Okay, and this is what we do in the call find in statement data definition. Then we do another thing that is also important, that is the symbol resolution. Now, in all programming languages, you can have expressions that contain reference to something else. For example, you can have the expression a plus 1, where a is a reference to a variable, to a parameter, to a field, to something else. Now, at this stage, we find all these references and, considering the scoping rules of RPG, find to what they refer to, and we add a link, a reference between the place in which we make reference to the symbol and the declaration, so that later we are able, when we see that a plus 1 is used, to know a to which definition of a corresponds, and for example we can figure out the type of a. And why this is important? Well, because sometimes elaborations need to know the type of the expressions involved, and the type of the expression is specified in the declaration. For example, if I have the expression a plus b, depending on the type of a and b, this could be an arithmetic sum or a string concatenation if a and b are two strings. So I don't know which operation I need to perform unless I figure out the type of a and b, which is known at compile time, so I can figure that out by navigating to the declaration. So I need symbol resolution for these and other purposes. I do the same things for invocation of subroutine and function calls, not from programs, that are instead resolved dynamically, so at execution time. Okay, so once I have built this understanding, I need to move to step 2, so to the actual execution of RPG code. And to do that, well, basically I loop over statements, I look at each statement, and depending on its type, I do something, where this something could be performing some side effect or maybe changing a value in the symbol table. Typically, in executing statement, I will also need to evaluate expressions that are contained in those statements. And to evaluate expression, I will typically need to access also the symbol table. Now, the interpretation is easy conceptually, because basically I have a big switch or a when statement in Kotlin, which I look at the type of the statement, and depending on the type I do something. For example, let's look at the first statement, which is an execute subroutine statement. I do some logging, and then I'm also doing some measurement of the execution time. We spend a lot of energy in tracking performance of these things, but the interesting lines is just one, and this one. In this case, we want to execute the subroutine that is defined in the execute subroutine statement, is a reference. We have resolved it as part of the symbol resolution step, so referred is actually a link to the definition of the subroutine. And so, given we have a link to the definition of the subroutine, we can take the list of statements and we can start executing them. You should know that a subroutine in RPG doesn't take parameters, so it communicates with the rest of our programs through global variables. It means that we do not need to instantiate a new symbol table, we don't need to pass value, we just take the list of statements and start executing them. Quite simple. Not all the statements are that simple, but this one is quite simple. And so this is in principle the approach that we use to execute statements. Now, to interpret expression, we do something very similar, because also in this case we just look at the type of the expression and do something that will produce a value. Now, some expressions are trivial to evaluate, and those are the literals. I could have in RPG a string literal, for example foo. In this case, foo will be evaluated to foo. Or I could have an integer literals, for example 1. Its value will be 1, will be specified in the expression itself. In other cases, I need to do some elaboration. For example, I could have a data reference, a plus 1, a is a data reference. In this case, the value is the value that the variable a, or the parameter a, the symbol that I'm referring to, as at this moment, and this value is found in the symbol table. So basically I go in the symbol table, take the value and return it. In other case, I need to do some elaboration. For example, we have an equality expression here. In this case, we evaluate the value on the left, we evaluate the value on the right, and then we check if they are equal, considering the RPG definition of equality. So it could involve some automatic conversion, but that's in principle what we do. Now, regarding the symbol table, the symbol table is from many point of view just a map. A map where I have as key my symbols, and I have as values the current values they have. So at some point I can have an assignment of variable a and insert into the symbol table that a is now value 3, and later I can come back, read the value of a, because maybe I'm using a in another expression, and I can retrieve that value by using a as the key and finding the corresponding value. So in principle, a symbol table is a very simple data structure. However, there are a couple of particularities that we have to consider. Projected arrays and coercion. Coercion means basically that sometimes, depending on where a value is used, we want to perform some automatic conversion. For example, between a number and a string, or vice versa. Projected arrays instead are something specific of RPG. For example, in this case I have an array of data structure. This array is called AR01, and it has a field phi07. Now in RPG I can treat IR01 as an array, so I can take, for example, the first element and then access the field phi07. But I can also treat phi07 as it was an array. So I can say phi07 and it basically means take the third element of AR01, my container, and then access that field. So we introduce the concept of projected array that permits us to support this usage, and we do that automatically inside the symbol table. Now, we are running out of time, and there are different things that are interesting about Jariko, so I will try to show them a few things. This is how we implement interaction between RPG and Java. Basically, when I have a Java programs that will start the RPG interpreter, because the RPG interpreter is substantially well, a Kotlin library, but a library that can be used in the JVM. Before I create the interpreter, I populate a registry. In this registry, I can say that certain programs, and I specify their names, correspond to certain Java classes. Then I invoke my interpreter starts executing the statements. When it finds the statement that executes a call to a program, it stops, it looks into the registry and see if there is a program, a Java program associated to that name. If there is, it invokes the Java program produces some result, the result is returned to the interpreter, and the execution of RPG code continues. If it's not found, instead, it will look in certain directories for an RPG program with that name and interpret it. So this is how we combine the two words. Now, another aspect that is very important, and this is an aspect that has been implemented as Sme.UP, so I don't know it as well as the rest of the interpreter, is the support for the runtime. Because you need to consider that a language needs to take advantage of the capabilities of its environment that are provided through the standard library. Okay, so in a way, RPG is powerful because the standard library of RPG is powerful, and the standard library take advantage of the functionality of the EBMI platform. Once we start executing this stuff outside the EBMI platform, we need to replicate some of this functionality, the ones that we want to support. Among them, there is the access of the database. Now, I don't want to dive into this, but we can just briefly say that our interpreter works with a system interface that permits to control the environment that is perceived by the interpreter. Among other things, it permits to specify a database interface. Database interface permits to obtain metadata and to have provide a DB files, because in RPG we have a different approach to database. We are not using a relational database, we are using something else. So we have the concept of file. Now, right now we have an interface that is JDBC compliant, so it works through JDBC, and basically perform a translation between the way that RPG perceives database and SQL. So now this is a part that I don't know as well as the people at Sme.UP, so I could say something stupid, so please forgive me. But basically in RPG we use the XAMPP paradigm, so we basically perform some call to position ourselves in a way a cursor inside the file, and then we perform other calls to move to the next of previous lines, and so read the record that is under the cursor. Is a completely different approach from SQL. So it was not easy to perform the mapping. So in this way, when we use code in RPG, we will keep using the XAMPP paradigm, but behind the scene this is translated into SQL. And this is not easy, and not easy to do that with decent performances. Now, another interesting thing that we have built in Jariko is support for unit testing. So we have the possibility of specifying basically assertions. In this case, for example, line 6, I'm checking that variable result has the value 1. Another thing that has been done as Sme.UP, they built basic support for Visual Studio Code, so you can have syntax highlighting for RPG program, you can invoke the interpreter, run the results, you can have unit testing be performed and see which annotation fail, and so on. And they also are able to access sources that are stored on the AS400 machine. So with a reasonable effort, they provide a basic support for programming in RPG using Jariko. Now, a concrete application that I think was interesting was this one that they're using at Sme.UP. Basically, they have a system that reads plates from cars that are approaching a gate. It checks on the database if this plate is associated with an employee. If this is the case, they open the gate. And this is a system where the code to find if a plate was associated with an employee was written in RPG, while the code that opened the gate is instead written in Java. So we have a mixed application with RPG and Java code. Now, in case you want to know more about this topic, here there are a few resources, a presentation I've given at Kotlin Conf, an article about writing transpilers that I think is connected to the topic of writing interpreters, a set of resources on building languages and related tooling. And I have these resources, later I can send them to you. Another interesting things that I've done as Sme.UP is putting a web page where you can go writing code, execute it, and see the result in the browser. We have many ideas for future development. Strumenta, we are thinking of offering the RPG parser, exclusively the parser through an API. Then we are thinking about writing an editor running in the browser using Monaco. And at Sme.UP they've written a prototype of our REPL, and they're working through serverless RPG. Final words about us. I'm the founder of Strumenta. We are a consulting studio offering services on language engineering, and Strumenta is Latin for tools, or Werkzeuge in German. So our goal is to provide better tools to help professionals to do their work. These professionals can be developers or non-developers. We build all sorts of tools to help them. We do that through language engineering, so we create parsers, compilers, interpreters, transpilers, editors, and this sort of stuff. You can learn more about this project visiting the GitHub page, and you can learn more about Strumenta visiting these websites, the website of the company and a technical blog. You can also write to me at any time. So, thank you very much for your attention. It's been a pleasure. Now we have a lot of time for discussion, at the conference at least. For people watching this video, they can just write comments or shoot an email to me. I will answer you. And thank you.